Hi, my name is Evgeny Iganov. I am a solution architect from Conformiq Software. I have a pleasure to present you second part of our Getting Started with Conformiq video series. The series will show you the whole process of testing with Conformiq. The series consists of 5 parts where we will focus on different aspects of automated test design with Conformiq. In the previous part 1, we have created a model based on the specification of the system under test, which represents the functionality to be tested. We considered main building blocks of the model: system block, which describes system under test interface; UML state machine diagram, which reflects system under test behavior in terms of states and transitions; and class file, where we can, for example, declare variable which we then can reference across multiple transitions in state machine diagram. We loaded our model into Conformiq and analyzed syntactical or compilation error reports. In this video we will consider the control of test generation via design configuration. Conformiq generates test case automatically from a model based on test generation control settings by pressing a single button. We will also review in this video the results of test generation, including human readable tests for review, test documentation, traceability metrics, and test coverage report. The review of tests is important, since Conformiq Designer may discover cases of covering our behavior that we didn't not think about. It allows us to deal with such cases before any test is ever executed. When we create a Conformiq project, Conformiq Designer automatically selects a default list of testing goals in the design configurations. In the first part we already generated 4 test cases using these default settings. Let's recall to our example system under test specifications, which is simple calculator. This calculator has a conventional keypad and display and supports 4 basic arithmetic operations. Let's go back to our Conformiq project, which we created in the previous video. In our previous session we generated test cases using default test control settings. Let's do it again now. Make sure you look at Console tab here to check for any warning or error messages. During test generation, Conformiq reports a division by 0 modal defect and counted a new modal defect division by 0. This defect is related to an unexpected but valid input that was not detected during the loading of the model. When I click on this line in console, Conformiq Designer changes its user interface perspective to Conformiq Debugger from Conformiq. You can toggle this perspective also manually. The Conformiq Debugger perspective contains several handful user interface controls allowing using to locate problem locations and even execute tests or defect traces in the model step by step. Now I select our model defect from the defect list and I choose bottom line in debug view. Conformiq Debugger highlights the problem in the model browser window with orange. From variable view we see that in the model we have created, Conformiq encountered a division by 0 operation violation during test generation. Please refer to our advanced video series for more details on working with Conformiq Debugger perspective. When Conformiq Designer generates test cases, it tries to inject all possible kinds of inputs to cover all parts and features of the model. If input leads to error, Conformiq Designer reports these issues and continues test generation. In our case, Conformiq Designer discovered a special case when a 0 is entered by the user as a second operand, and illegal division by 0 is caused. But actually this special case is not mentioned in the specification. Let's fix our specification. We have just added a new requirement FR341 and let's update now external interfaces view of our calculator as a black box. In addition to numbers as output data, the calculator needs to display also textual information to the user in case of an error. So let's add a text output record type to display port for this purpose. And now we will implement this in our system block. First, I will add a new text output record to the list of records of port display inside the system block. Then we add text record definition itself. I will remove the final state and introduce a junction from toolbar to handle the different cases of division. You can use junctions for splitting the behavior of state machine. Now I will add a condition that needs to be satisfied in the transition guards. The else keyword can be used on one of the outgoing transitions to indicate that it is only fired if all other guards fail. Now I will cut and paste the division functionality to our corrected transition. At this point we have handled the case of division by zero and corresponding model defect is eliminated. Now let's add the expected response by system under test in case of division by zero violation. Now the user is informed about the incorrect entry with text message. And we go back to Conformiq Designer. Let us generate test cases again. There are no errors or model defects reported. Conformiq has now generated 5 test cases. Let's review them. Test cases are shown in test case list view. When you select a test case in this view, a corresponding message sequence chart is shown immediately in a test case view. The screen shows the sequence of all incoming tester to calculator or outgoing calculator to tester messages with computed timestamp. The test case view has several outlook options. If we toggle show tester ports, then the tester lifeline gets expanded into several lifelines, one for each external ports. Now we can identify key part and display ports. At the same time, when you select a test case, you can track it in model browser view. The test case path is highlighted with bold. This feature is very helpful to get a first idea about what functionality is covered by a specific test case. The actual content of messages communicated through ports is shown in test steps view. A quick look tells us that our first 3 test cases differs only in step 3, where operation is different. While both arguments are 0. Let's look at test case 4. Here user enters 0 as first argument. Note this value was automatically generated by Conformiq, and we did not specify it in our model. Conformiq chooses this value based on the restrictions in our model. Actually, for numbers we didn't specify any restrictions, So all the numbers are equivalents and Conformiq has the freedom to choose a 0. The calculator displays the first arguments to the user. Outputs are always completely computed from the model and input signals. And Conformiq generates here an output of 0 since the calculator shall display the first argument entered by the user. Then the user pushes division button. For the operation we restricted valid entries by guards to addition, subtraction, multiplication and division. The calculator still correctly displays the first arguments to the user. Conformiq generates here again an output of 0 since the calculator shall display again at this point the first argument entered by the user. Then user enters -1 as a second argument. Again this value was automatically generated by Conformiq from the domain of non-zero numbers to cover successful division without arithmetic violations. The calculator displays the second argument. Conformiq generates here again an output of -1 since the calculator shall display at this point the second argument entered by the user. Then user pushes the equal button. And finally the calculator displays the result of division of 0 by -1. Conformiq Designer calculates an output of 0. In order to produce this test case, Conformiq selected three inputs, number 0, operation division, and number -1, based on model restrictions and Conformiq's coverage goals. Based on these inputs and guided by our model, Conformiq computed corresponding outputs. In the test case 5, the last test step covers the division by 0, which results in the correct display of the error text by the calculator. All views I have mentioned are fully interactive and linked to each other. If I choose one test step in test steps view, corresponding message communications is selected in test case view, and corresponding functionality of model is covered in orange in model browser view. Now let's talk about coverage editor and design configurations. As you remember in the first video, we skipped DC1 entity in our Conformiq project. When you double click on it, Conformiq shows coverage editor. It is your main view for controlling test generation process. In this view, we see a column called DC1. This is our design configuration. A design configuration captures the list of testing goals to be covered by the test cases, as well as their coverage by the current test cases. By default, a Conformiq project contains one design configuration, and you can add, however. In addition to coverage view, I will show you how you can use this view for guiding test generation process. First, I will delete generated test cases, and please monitor how this view changes. All green hundreds have been updated to red zeros. This means nothing is covered, since we have no test. Every time when Conformiq loads a model, it extracts from it a list of checkpoints or possible testing goals and displays them in the coverage editor. Testing goals are shown in groups. Please notice, when you delete test cases, Conformiq does not unload the model. Let's expand, for example, the state chart group. It contains checkpoints from our state machine diagram. For now, we will only consider the checkpoint states and transition. Every state and transition is associated automatically by Conformiq with a checkpoint, and it's listed here. The state subgroup contains the list of all states in our state machine, including final states extracted from the module. Notice again that view is interactive and linked to the module browser view. Whenever I choose a state or transition or any other checkpoint in the coverage editor, Conformiq Designer highlights it in module browser. Transition group lists all the transitions extracted from our state machine. Yellow exclamation marks in the right column of the coverage editor indicates that our current state suite does not have any test case covering this state or transition. The red zeros indicate the 0% of covered checkpoints in a group. Notice that we have currently 0 test cases generated. In this view, we can specify target checkpoints list, which will guide Conformiq Designer in test case generation process. When we left click on one of the green or gray ticks, Conformiq proposes to change its state to target, don't care, block, inherit, or assert. A green tick or target means that checkpoint or group of checkpoints is target, and Conformiq Designer will make an effort to cover it. A gray tick or inherit means that checkpoint status is inherited from a default group value. In our case, all states and transitions are targeted, since the upper group state chart has a green tick. A black dash or don't care means that Conformiq will not make a special effort to cover a corresponding feature. This checkpoint may or may not be covered by chance when trying to cover any of targeted checkpoints. A red X or block means that Conformiq will generate test suite avoiding this checkpoint, and not a single test case shall cover this checkpoint. Now let's make an experiment. We have updated our specification by adding division by zero situation handling, and we have updated our model accordingly. Let's play a common industrial scenario. Specification has been changed, the test cases have been updated, but system under test is still outdated. It does not support division by zero in our case. We need to block the behavior of our model implementing this division by zero to build a good test suite. I have just blocked the transition which is processing division by zero behavior. Let's generate test cases again. And please monitor a console output. A console output states that 93% of targeted checkpoints are covered. More detailed information is shown in coverage editor. We see that in addition to not covering the block transitions, now only 90% of states are covered, and one of the final states is not covered. We did not explicitly block this final state. However, we blocked the division by zero transition, and there is also no way as a consequence to reach or cover this state with a test. This effect you need to keep in mind when blocking testing goals, and may be the reason why specific testing goals is not. Please note, the module browser also shows the module parts which have not been covered in red. So, due to explicitly blocking the coverage of one checkpoint, we got only 4 test cases. Now let's talk about another very powerful analytical tool called the traceability matrix. It is a table which lists all checkpoints of the module are listed versus all generated test cases. An X marking in a cell means that particular checkpoint is covered by a corresponding test case. For example, you can see that the final state 1 is covered by the first test case, and state wait for equal is covered by all the test cases. We can use this view, for example, to quickly identify and select the tests that cover a specific testing goal that we are interested in reviewing. In Coverage Editor and Traceability Metrics, you can also find other checkpoint groups. Please refer to Conformiq Designer manual for details. Next, let's unblock division by zero and generate test cases again. Notice, you don't need to delete existing test cases prior to a generation. Conformiq actually performs an analysis of existing test asserts and incremental test case generation, and even manages the test sets for you. We have again 5 test cases back. Conformiq has kept all the valid test cases and brought back our previous test for division by zero with the same name and number. Let's play a bit here to understand what happened. Let's assume that some data handling has been changed in our model. A simple example, the error text of division by zero use the number 0 instead of text 0. And I will save the change. Now let's keep existing test cases and see how Conformiq manage our test set. What has happened? The test case 5, for example, is marked in red, which means that it's invalid. This is our test case covering division by zero. So prior to generating tests, Conformiq has performed a test case analysis and taking my existing tests into account. And Conformiq determined that this test case 5 is invalid. Why is this test case invalid? Because the data output used in our previous test does not match the output computed from the updated model anymore. The expected error message differs. In addition, Conformiq has generated a new test as a replacement for this test case 6. Actually, Conformiq has used the existing test cases that pass the analysis phase to speed up the generation of new test cases. This is called incremental test generation, which will help you to get results quickly with more complex models. This new test case 6 uses our updated error message with number 0. I will revert the changes now. And let's generate test cases again. Now test case 5 becomes again valid and shown in black, and now test case 6 is invalid. So Conformiq does not only take existing tests into account, but even tests from previous test generations. Once you delete the test cases, however, you also lose this history. To filter out again display of invalid tests, we click again on the design configuration in the project view. This ends our introduction into test generation and review, and we proceed to our summary. In this video we have considered modal defect handling. We have successfully located and resolved a modal defect in our model in Conformiq Debugger perspective. We learned how Conformiq helps to discover incomplete specifications, which can lead to modal defect. We improved the model so that it covers additional scenarios. We introduced the use of junctions to implement conditional branching of modal behavior. I demonstrated the usage of keyword else in transition guards. We reviewed design configurations and coverage editor, two very powerful tools for controlling test case generation. We explained how Conformiq Designer automatically extracts a list of checkpoints from the model and displays them as testing goals in the coverage editor. And we showed how you control test generation by modifying target checkpoints in a design configuration. Conformiq provides a set of tools for generated test suite analysis, test case view and test step view representing message sequence charts, and traceability metrics providing extensive coverage report. We made an experiment to answer the questions: what happens if I change my model and generate test cases? Conformiq generates test cases incrementally. It keeps existing tests as long as they are valid and automatically marks tests as invalid which don't conform to our model behavior. In next video we will consider several other test generation controls and show you how you can annotate model with specification requirements.